Yes.
Sir, is this data structure using Java?
Yes, madam.
Yes, sir. Thank you.
Yeah. Good evening, dear friends. So today
Yes, sir. Good evening, sir.
we are going to start the first class, and it will be continued if one more class also after 11th. So the subject is data structures using Java. So in this, we are going to know about the definition of data structures, and we will see what are the various types of data structures, and we will also see uh, one particular kind of data structure today. So please listen carefully, and at last 5 minutes, we will have some discussion to clarify your doubts. So first of all, what do you mean by a data structure? Anybody can define it if you know?
Data structure is defined as the data available which is not being processed as an information.
Okay, ma'am. Okay. We can define in many ways. And one definition of data structure is, I don't know, why I'm not getting my screen. Is my screen is visible? Some paint?
It's a notepad is visible, sir.
Yes, yes, that's what. Data structure. You can define in many ways. Data structure is the way of arranging data in a computer so that it can be accessed and updated efficiently. It is a way of organizing or arranging data in a computer in order to access and update efficiently. And you can define another way. Data structure is a storage that is used to store and organize the data. How efficient you can organize your data in a computer. So that's what data structure. And there are various types of data structures are available. What there are some, there are mainly two types of data structures are available. One is linear data structure and other is non-linear data structure. DS means data structure. So what do you mean by a linear data structure? A linear data structure is the data structure in which the elements are arranged in sequential manner. That means one after another. So elements are arranged in a sequential manner, then that data structure is called linear data structure. So what are the various examples for this linear data structure? Can you say? Linear data structure.
Uh, for example, if we are trying to access an employee details in
No,
a
no,
portal.
example data structure we are asking. That is an array, stack, queue, and linked list. These are the linear data structures. These data structures allows us to store the data in the sequential order. Array we know, and stack we have discussed in the class. Queue again we will also discuss, and linked list. What are the type? What are the operation? What is a stack? What is an array? What are the operations can be done on stack? And what is a queue? Is there any types of queues? What are the various operations can be performed on queue? And what is a linked list? Its types and operations that we are going to discuss in these upcoming classes. And coming to non-linear data structure. Linear data structure means data will be arranged in a sequential manner. What about non-linear data structures? Unlike linear data structures, the elements in the non-linear data structures are not arranged in sequential manner. Linear, non-linear. Linear means sequential order. Non-linear means not in sequential order. So how that can be? Instead of the sequential manner, the elements can be arranged in hierarchical manner to connect one element with others. So we can define nonlinear data structures into uh, two categories. One is tree and other is graphs. Tree data structure and graphs. Uh, Non-linear tree DS and graph DS. Again, in tree data structure, we have various kinds. Like, can you say some names?
Binary structure tree,
Binary
BTS,
tree, binary search tree.
BST.
No, BST is nothing but binary search tree. First one is binary tree,
Binary tree, binary search tree.
binary search tree. Then again, AVL trees, B trees, B plus trees, red block trees, splay trees, and more. So our syllabus is covering about binary trees, binary search trees, AVL trees, and B trees, B plus trees, and red block trees. So that we are going to discuss about the tree data structures today. In that, whatever is the possible, those many topics we will cover. So first of all, let me recall it. The data structure is arrangement of data in the computer memory to access and update efficiently. Or you can define in some other way. Data structure is the way of storing data in the computer in order to access very efficiently. That you can define. And coming to the types of data structures are mainly two types. One is linear data structure and other is non-linear data structure. Linear, you can simply, by the word it, by itself, you can identify. Linear means that the elements can be arranged in a linear manner. That means sequential manner. And we have various types of linear data structures. They are arrays, stack, queue, linked list. And coming to the non-linear data structures, these are the data structures in which the elements are not arranged in a sequential manner. Rather, and instead of sequential manner, the elements can be arranged in an hierarchical manner. So we have two types of non-linear data structures. One is tree data structure and other is graph data structure. So today, I just want to focus the important topics of this tree data structure, non-linear. We will complete these three data structures. Then we will see about graphs and we will see about stack data structures. Let me start with a non-linear data structure, that is tree. A tree data structure is the data structure in which the elements are arranged in a hierarchical manner, and the data elements can be connected with one with other to form a tree structure. So in the tree data structure, there are some basic terminology. If you know those terminology, and it's easier to understand the remaining uh, tree data structures. The first one, the basic terminology of tree data structure. Three Ds. The first one is node. Can someone say, if you know, what do you mean by node?
It's a topmost element of the tree, sir.
That is root, ma'am. I'm
Pardon?
asking, I'm asking node.
Node is the connected element of the tree, or which is having at most two children, or with each other. It's
Uh,
a at most two child nodes.
that property is belongs to some other tree, madam. Actually, every tree should have some nodes and some terminology. In that,
Hmm.
the node is very basic one. The node you can define in a node is an entity that contains keys and pointers to its child nodes. Uh, you can node is an entity that contains keys. I have underlined, please note it down. And pointers to its child nodes. That is node. And coming to the next one, second one, edges are edge. This one. Simply you can say connecting links. Connecting links of any two nodes are known as edges. If you want, you can note it down, friends. And one more one, it is leaf node. Can someone define, if you know?
Leaf node, sir.
Yes.
It's the last node of tree, sir, where nowhere the other nodes are connected.
Yes. That means the node which does not have any child nodes.
Hmm.
Yes, these are very important terminology. And degree of the tree. Degree of a tree, you can say, or degree of node also you can write. Degree of a node. Is it visible to you?
Yes, sir, visible.
Change the color. Degree of a node. This is the total number of children of that particular node. The total number of children of that particular node is called degree of a node. And levels of, can I erase it?
Yes, sir.
Yeah.
You can.
Levels of node. In a tree data structure, levels will start from the root node. The level of root node is level 0. The level of root node is level 0. And level of children of leaf root node is level 1 and so on. Next, height of the node. Height of the node. The total number of edges from leaf node to particular node. The total number of edges from leaf node to particular node in the longest path is called height of that node. Can I erase it?
Yes, sir.
Yeah. I'll discuss all these with examples, don't worry. Next, depth of the node. Depth of the node. The number of edges from root node to a particular node. Next, parts of a data node. Left child, right child. Can I erase it?
Yes, sir.
Okay. We will see these terminology with examples. If you take a, let me get some picture. Can you see the picture?
Yes, sir.
Yeah. Here, the very first one is the node. This is what a node, and this is the link is called edge. And what we have discussed the other ones? Can you recall it? Node, edge, and
Leaf node.
exactly. The node which is not having any children. What is the children? What are the children of node 1, 2, and 3?
2 and 3.
Yeah. What are the children of 4 and 5?
No children.
No children. The node which is not having any children is called leaf nodes. And what are the leaf nodes here?
4 and 5 only, sir. Even
Can
3
you?
also.
Yes, leaf nodes. 3, 4, 5. Because these nodes are not having any children. Uh, what is the next one?
Next one, it is coming to degree of nodes.
Degree of nodes. What it is?
It is the total number of children of that particular node.
Yes, it's called degree of node. Can you say what is the degree of node 1?
No, node 1, it is 2, sir.
Node 1, it is
2.
2. And what about node 3?
Node 3, no, sir. 0.
0. Because node 1 is having how many children? 1,
Node 1 is having 2
2.
children.
Yes, this
Whereas
degree is 2. And this 3 is not having any children. Its degree is 0. And what about degree of 2?
degree of 2 is another 2.
Yes, 2. And what about degree of 4 and 5?
0.
0. Because there are no children for 4 and 5. Nice. Next one.
It's levels of node.
Levels of node. So we have discussed what is the level of root node. The levels starts from 0. This is root node is level 0. And this is level 1. This is level 2. So if I draw this one like how many levels are there in this? Hmm?
0, 1,
0, 1, 2,
2,
3.
4.
This is also 1, 4.
4.
So the levels of this particular tree is the level of is 4. What is the next one?
Height of the node.
Height of the node. It's can you define it?
Total number of edges from leaf node of particular node.
Total number of edges from leaf node
Leaf
to
node to particular node in the longest path.
yes. If you take this tree, you take this longest path, this one. If you go in this path, what is the height? There are two paths are there, no, for one. This is one path and this is other path, which is having longest path. 1 to 2 and 2 to 4 is the longest path. So you have to consider only the longest path. In that longest path, how many edges are there?
2.
In the, yeah, this is one path, only edge, and this is one edge. No, this is the longest path. Though, so the height of this node A is 2. If you say the height of node 2, what is the longest path? How many paths are there? This is one path and this is one path. Both are having same. So what is the height? Height of node 2.
1, sir.
You have to consider only one path, which is longest. If both are same, you can take any path. Only one path you have to consider. This if I'll take this one. So the only one edge is there. So height of this 2 is 1. And what about this height of this 5? Does it have any paths? To its
No.
downwards only. No, no means its height is
0.
exactly. Nice. Next one, what we have discussed? Is it depth?
Yes, sir.
Depth of node.
Yeah. Can you define?
Number of edges from root node to a particular node.
Number of edges from root node to
Particular node.
a particular node. So here if you take 1, what is the depth? you have to consider from root node to particular node. If you take only root node alone, the depth is 0. If you take from root node to particular node like 2, root node to 2, what is the depth? How many edges are there?
1, sir.
Only 1. From root node to 4, how many are there?
2, sir.
2.
2.
Two.
That's it. If you take from root node to 5, this is 1 edge. From root node to, you have to consider, no, root node to 5. This is 1 edge and this is 1 edge. If we have one more edge like 6 here, one more node. From root node 1 to 6, what is the depth?
3, sir.
3. Because 3 edges are there from root node to 6. Then depth of 6 is 3. So we will discuss about other topic we have discussed, I think so.
Parts of data node.
Yes. A tree will have 2 children. Here it is 2 and 3 for 1. One is left tree, another is right tree. Is there any other nodes after 3 which is attached to 3?
No, sir.
No. If you go towards left side to 1, if there is a tree, then that is called left subtree. Left subtree. If you go right, then this will be called right subtree. Got it? We'll see once. One more example we'll see. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you see from root node 1, this is called left subtree and this is called right subtree. Got it?
3 to 9 sub.
Sorry? Take this one. This is root node and this is left subtree and this is right subtree. Right subtree and left subtree. And do you have any right subtrees and left subtrees after 3? If you consider 3 as the node, it is left subtree and this is right subtree. And if you consider 2 and this is left subtree and this is right subtree. If you consider 6, this is left subtree and this is right subtree. And we will see binary tree. What is the property of binary tree?
It should have only 2 children.
There are only 2 children. The property of binary tree is it should have at most 2 children.
At most, that is important.
Maximum 2 children. 1, this is 2, this is 3, 4, 5, 6, 7, 8. Is it binary tree?
Yes.
Yes,
Yes,
sir.
it is binary tree.
You think and say.
Every node should have
Because it is having at most two children.
Is it binary tree or not?
Yes, it is a binary. It's a binary tree, sir.
Sure, madam.
Actually, 8 is not having any children.
Can I expect some answer from somebody else? Is it binary tree or not? Anybody? Say yes or no, yeah.
Yes, only.
Sir, it is binary tree.
You think and say.
Sir, yes, only.
Ma'am, you think once again, please.
No, sir.
Yes, sir.
Who is saying no? Why no, madam? May I know? Please, time is running out.
This is a binary tree, sir. Each parent, they have two children.
Okay. So it is not binary tree you are saying, ma'am.
This is binary tree, sir.
Binary or not?
It's a binary.
Okay. Ma'am, Gauri ma'am, what you say finally?
Finally, I say it's a binary tree.
Okay. Yes, it is a binary tree. Because what is the property of binary tree? Every node should have at most two children. Means maximum two children. Minimum it can be 1 or 0. Getting
Correct.
the point?
Yes, sir.
You can take this node. You can take this node. How many children it has?
2, sir.
2. And what about 2? How many children 2 is having?
2, sir.
Two
2.
children.
What about 3? It is also having 2 children.
2 children.
And what about this? 7 is
8
having
is
1.
having no.
7 is having 1 children. A node can have 0 children or 1 children or 2 children. This is the maximum. You take 4. Does it have any children?
No, sir.
No. No means it is 0.
No.
The property of binary tree is a node can have 0 children or 1 or 2. It should not be not more than, it should not be like 3. It should not have like this one.
Yes, sir.
Got it? This is what binary tree. Okay, friends. If I ask you to construct a binary tree, this is important somewhat. 7, 4, 8, 9, 15, 16, 20, 2, 1, 35. Can you say how this binary tree will be formed? The node, first node, whatever you take, that will be a root node.
7.
Yes.
Okay. Now,
Then
4.
4 is left
Left side 4. Right side 8.
okay.
And 4 left side 8.
8.
Wrong,
9
wrong,
and
wrong.
9,
No,
sir.
no, no. 8 is more than
Sorry,
it
sorry.
will
9.
be.
9.
This is binary tree.
Yes.
It should have to do that.
Is it 9 placed correct only?
No, sir.
4 left. No, sir.
Why no?
Correct.
9 it should be placed right side, sir.
No, madam, you are absolutely wrong.
That is in BST, sir.
That is
Yes,
the
this
binary
is
search
binary
tree.
tree, not BST, not binary search tree. This will go like this only. 9, 15, again 16, 20. This
2,
is 2,
1.
This is 1.
35.
That's it.
Yes, sir.
It will go like this. This is only the binary tree. It won't consider any properties. The thing is, it should have, every node should have at most 2 children. The elements will be placed immediately to the nodes. This is what binary tree. It's as easy as you understand. Coming to the binary search tree, and it is important that to construction of this binary tree and binary search tree, BST, binary search trees. Can you say the binary search tree is also a binary tree? A binary search tree is also a binary tree, but it should follow some rules or properties.
Step by step.
Yeah. What are the properties of binary search tree? Means the first property, all the nodes is mute, which are lesser than the root node should be placed in left subtree. Next, all the nodes which are greater than the root node should be placed in right subtree. These are the 2 important properties of binary search tree. So you have to construct the binary search tree by following these 2 properties. How can you define what is a binary search tree? A binary search tree is also a binary tree with the following properties. What is the first property? All the nodes that are lesser than the root node should be in left subtree, and all the nodes which are greater than the root node should be in the right subtree. This is what the property of binary search tree. You may get this question. This is very, very important actually. The binary search tree and binary tree. I think almost all the trees are very important. AVL trees, splay trees, red black trees, and all this. Can I ask you to construct some tree? Can you tell me step by step? You have to. We'll take small example to construct. Construct a BST with the following nodes or following elements. This is 5, 6, 3, 10, 15, 2. Yeah, we'll take till this. So how will you construct this tree?
First steps will be 5, sir.
Yeah, you please look at this, and the exam also you have to
Step
write.
1, 5.
Step 1.
5.
The first element is 5. This should be the root node. This is what. Next,
Second step.
step 2.
Should be
Second
The
element.
next element, please, pen.
root.
The next element is 6. 6 is, you have to compare with the existing node. What is the root node? 5. 6 is greater than 5. So, it should go to the right subtree. So, how it will come? What is the first element already existing? 5 is there and 6 is greater than this, no? This one. Next, step 3. What is the next element?
Next element is
Step 3. Yeah, ma'am, please continue. The next element is 3. 3. 3 is lesser
greater
than
than
5. It should go to
right.
left subtree. Not right. Left only, no? So that it will come like this. 5. Here 6. Here 3. What is the next step? Can I erase this?
Yes, sir.
10, 15 and 2 is there. I'll write the elements again. Five, 6, 3, 10, 15 and 2. Step 4. The next
The
element
next
is
element is 10.
Is 10. You have to compare 10 with root node. 10 is greater than 5.
Right.
It should go
Right
to
side.
Right side.
right subtree.
Again,
And
15 also 10 right side.
here it is 6 already existing. So 10 is greater than 6. So it should go to right of 6. So how the tree will come? 5, 6, 3, 10. What is the last step?
The next
Oh,
element
sorry, next
is
step is 15 is also there.
15. Yes, sir.
Yeah. Can you
15, it will go to, yeah, it will go to right side of 10 because it's more than 10.
tell? First, you have to compare. In the next element is 15. So 15 is greater than 5. It should go to the right subtree.
Yeah.
Again, it is 6 is there in the right subtree. And 15 is greater than 6.
Then it should
So
go
it
to
should
right.
go to the right subtree. Again, 10 is there. So 15
It
is greater than 10.
Greater
So it
than 10.
should go to the
right side of
Right.
10.
right side of the 10. So it will come like this. Then last one. Step.
Last element, we
Yeah.
can't see number.
Now the last element is 2. When you come, 2 is
Number.
lesser
We
than
can see the
5.
number on the screen.
So it
There's
should
a
go to the
three.
left subtree. And again, 3 is existing here.
Yeah.
And 2 is lesser than 3. So it
Then
should
it
go
goes
to
to left side of 3.
this is what?
Binary history.
Yeah, this is what the BST. I want you to construct the binary search tree for the following elements. The elements are 50, 15, 62, 5, 20, 58, 91, 3, 8, 37, 60, and 24. We have only 2 minutes time. You
We'll
have
wind up quickly.
this
Yeah.
is you have to construct the step by step, and finally you can tell me what is the tree. You if you get this one in the exam, or if you want to explain this something somewhere else, you have to do it step by step.
Yeah, first to take the first node as 50.
1 minute, madam. 50. Now,
Then when the next element is 15, which is lesser than 50,
yeah,
it comes to left side of
we have
it.
only 1 minute time. You can answer, ma'am. You can tell it fast.
Yeah. And next element is 62, which is greater
62.
than 50, comes to right side.
And
Another one
20.
comparison will be done with 50 and 50. And 20, it will be left. Again, 58, it comes to left of 62. 91, it's come to right of 62. And 3 comes to left of 5. Whereas 8 comes to right of 5. 37 comes to left of 58. Sorry, right of 20. And 60 comes to right of 58. And 24 comes to this is left of 37.
This is what?
That is.
This is what the BST. You can indicate route like this. The arrow indicates that the route 1. So you have to explain step by step. And you have to construct the tree step by step also. I think at any time the host may close the session. Better to note this question. They may ask BST, AVL tree in the exam.
AVL tree only, it was a little confused for
Don't
us.
worry, ma'am. I'll take the class, I'll explain. Don't worry about the AVL trees.
If we are not understanding, we called as an evil tree.
No. I'll explain each and every tree, each and every linear data structure, and some hashing is also there in each and every graph. Don't bother about that.
Yes, sir. Yes.